Okay. So this is a Fundamental Mathematics for Robotics course, lecture number 2. This is the real start of this class. So there are 2 introductions, robotics and mathematics. And the first one will talk about mechanics of robots. Mechanics meaning that the hardware, how hardwares are actually modeled. Robot consists of those parts, those doesn't change shape. It's called the links, and joints, which connects links, and the angles changes. So robots are kind of collection of bunch of links and bunch of joints. So the robot posture. Robot posture here. This one here is a kind of fancy word for the shape. The shape of the robot is determined by the joint angles, right? So set of joint angles is pretty much what the shape is all about. So we identify the set of joint angles and the posture. So whenever we have a set of joint angles, that is a posture, shape of the robot. Okay. Trig functions. Trigonometric functions. Can you pronounce that? Well, I hate to pronounce this whole thing, so I just eliminate that and I'll just call trig functions. Well, sines and cosines. We use that quite often because there are a bunch of those rotating joints. Okay? So those are used to calculate the positions of this link, that link, etc., using the joint angles. So the simple example here is a 2-link manipulator. Well, interesting thing is that this one actually has 3 links, right? Link 0, 1, and 2. But link 0 is normally connected or attached to the ground, so it doesn't move. So therefore, link 1, link 2 are the only 2 which we are concerned. But that's why we call that 2-link. And an end-effector here. That's the one actually grab the parts or the tools and so forth. So we call that end-effector and abbreviate as EF. And actually, there is a joint here between the link 2 and end-effector. But we will ignore that for now to make situation simple. We will look at that in one of those homework problems. Okay, so this is what we have as a 2-link manipulator. So we are going to analyze this one here, meaning that if you have joint angles, then where this one is, blah, 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 etc. Okay. Before actually going into those calculations, probably it is easier to visualize what's going on. So I'll show you the movie of one of our robots. This is called the Sakura 2. And Sakura 2 is trying to open that door. So first, move the end-effector to the position of the door handle and grab the door handle and rotate the door handle and then pull. That's the motion it does. Since this was a trial run, so it is very cautiously doing it because we don't want this robot to break the door. Well, this one is powerful enough to be able to break the door. But if you look at it, you have, so those joint angles need to be specified for that end-effector to be at a certain location, right? So that's what we are going to talk about. How do we specify those joint angles so that the end-effector is at the position? Okay. Of course, there are a lot more joints and it itself moves around. So when you do this one, actually, you have to do a lot more than that. So the first questions we have is how how can we move end-effector to a point like this one here? But before that, you're talking about a point. But how do you specify that point? Point. Here? What do you mean by here? Robot doesn't understand the word here. Okay? So how do we specify a point in 2D space? Because that two-link manipulator can move only in this space. All right. We all know the answer. We need a coordinate system. Coordinate system meaning that x-axis, y-axis, and the origin. This set of three things. That's what we need. So how do we place those axes? Okay, we have a model of the robot, and we have to place this one somewhere. So how do we do it? This is our approach. First define where this origin is, and then decide x and y axis. Okay? Let's do it. Aha! The answer is already here. The origin is center of joint 1. Remember that the link 0 is connected to the ground, so it doesn't move. So therefore, the position of joint 1 doesn't move, although the angle does change. So this is a nice place to choose the origin. Then, next, x-axis is this one here, horizontally to your right, because normally we talk about right-hand coordinate system. So therefore, to your right. And then, y-axis, of course, is vertical upwards. So now we have the coordinate system. How about the positions of the joint 2 and the end-effector? Those are the places where it moves around. So we give names to those places. So joint 2 is called x1, x2, and end-effector x2, y2. Well, let's look at those on the diagram and picture here. Joint 2, y1, x1, and end-effector here, x2, y2. So now we have almost everything, but we do need a little bit more than this. Okay, so we are going to compute, say, x2, y2 in terms of what? Of course, the joint angle. If we do know the joint angles, then we should be able to compute this one here. So how do we define joint angles? Well, if you were a good student at high school, you know that you have learned counterclockwise from x-axis. So you have this, x and y, and angle is measured from the positive side of x-axis counterclockwise. Clock moves this way, right? So counterclockwise meaning the other way around. So this is high school mathematics. So we're going to use this one. Haha. Not that simple. We don't do that. How we define angles is totally free. I'm going to talk a lot more about this one here, but as far as robotics is concerned, there are a lot of things which are free. So this is our choice. Theta 1 clockwise from y-axis to link 1. And theta 2 is once again clockwise from link 1 direction to link 2 direction. Okay, let's take a look at it. Okay, so theta 1 here is from y to link 1 direction counterclockwise. Theta 2 is from link 1 direction to link 2 direction here clockwise. That's my choice. And I will show you why I have chosen this. Okay. Actually, although I said it's all totally free, but actually there are things which you may need to consider. The way angle is measured in the real robot I'm talking about is up to how the angular sensors are attached to the joint. Of course, to measure the joint angle, you attach some kind of device, okay, angular sensors. And how you attach the angle sensors to the joint will determine how the angles are measured. So you follow this, then you will automatically have suggestions. Okay, a trick. Okay, let's look at this Trig Manipulator from behind. You are looking at this side, right? If you look at from the other side, how does it look? Well, it's like a mirror image. So it will look like this one here. And let's superimpose the coordinates and angles definition on all of those. Then it will look like this one here. Okay, x-axis, x-axis goes to left-hand side. So this is not even a right-handed coordinate system. And the joint angles, theta 1 goes this way, theta 1 goes to this way, clockwise. No, counterclockwise. This one here, once again, this is counterclockwise. So the direction of the measurement of joint angles are reversed. Okay. Well, we have not changed anything. We just changed the way we look at the robot, and everything changes, right? So if we started from this one here, probably you would choose x-axis to the other way around, etc., etc. So it is totally free. You can choose any way, because any way you choose, if you look at from the other point of view, then it will be looking differently. So once again, coordinates and angles, those variables are freely defined, and forget the restrictions you learned before in high school. It is nice to remember those, how you define blah, 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 but good thing about university is that the things becomes much more free compared to the high school. Okay, so there are a lot more freedom to do things. This is one of them. You can freely define the variables and coordinates. So then what is the point here? How do you define? Yeah. This is the criterion, ease of use. Depending on how you define those variables and coordinates, the equations become simpler or more complex. So you should choose them in such a way that it is easier to use. Of course, you don't know how to define it, right? That's where experience comes in. You have to do lots of those things. And I'll give you some homeworks for that. Why is this possible or necessary? As I said, I'm repeating many links and joins, many possibilities. Yes, of course. So once you decided coordinates and variables, what is important? And this is so important that I will be repeating again and again. Recording all the definitions. How do you define variables and so forth? You should record it. You should have a list of those so that, or the diagram of it, so that people can find that. Otherwise, people cannot understand your equation. This is no. The recording definition is important for any discipline, engineering discipline. Anywhere you go, it is difficult. It is important. But especially so in robotics because of the freedom, abundant freedom. You have too many freedoms, so you have to write them down. Okay, so now we have all those definitions, angles and etc., etc. So we can get started with analysis. Namely, we can start computing end-effector position. So we have a tool to do that. We do need two more things, but anyway, let's get started. Well, end-effector position changes as the position of joint 2 changes. So let's first compute the joint 2 position, then end-effector position. Okay. To do that, this triangle, those two triangles are very handy. This first triangle here, comes from this triangle. So the position is this point here, is this one here, A. And the other triangle is this one here. So the position of end-effector here is position of C. So if you can compute the position of A and C using those two triangles, then you can find the location of end-effector. let's get started with a simple one. Okay. So point A, this is right angle, and this is the angle theta 1, and this is theta 1. Okay, so we can use the definition of sines and cosines. X1 here is L1 times sine theta 1. That's the definition of sine theta and sines. And this is cosine y1. So you can write down those equations right away by just taking a look at that triangle. Okay, then how about point C? With respect to this triangle, I call this I give a name for this angle, an alpha. Alpha is the first character in the Greek. So we have a right triangle again, so and L2 is here. So you can compute this and that. And this one here, this one here is that. So that's y1 minus y2, here, this one here. And the other one here is this one here. So that's x2 minus x1. So note the difference between these two. This one is y1 minus y2. This one is x2 minus x1, okay? But anyway, so this is alpha. So L2 times sine alpha is this one here. So therefore, okay, x2 minus x1 is L1, L2, L2 times sine alpha. And y1 minus y2 is L1 cosine alpha. So we have y2 and x2. So we can solve those two equations for x2 and y2 as like this one here. So x2 is x1 plus this one here, and y2 is y1 minus this one here. The difference is this, okay? Because of the difference, we have x2 minus x1 and y1 minus y2. All right, so what's next? Well, alpha is something I give just a name, right? So we have to know what alpha is in terms of theta 1 and theta 2, because those are the joint variables which we can use. And I use that here. This is pi, which is theta 1 plus theta 2 plus alpha. This is theta 1 because those are vertical lines. So theta 1 and theta 2, theta 1 here, then this is also theta 1. So what it amounts to is this. Come on. Here comes. Theta 1 plus theta 2 plus alpha is equal to pi. Therefore, alpha is pi minus this one here. Now, you can compute sine alpha, cosine alpha to be this. And now is the time to remember high school mathematics. You know that there is an identity saying that this one here is a sine, this one here is a minus cosine. So we can substitute them into that equation here and get those two equations. So minus and minus cancels out, becomes plus. The only thing you have to do is to substitute x1 and y1 and final equation here. So I said ease of use. How do you define those variables is up to the ease of use. But if you look at this equation is very nice. It has a pattern. It shows a pattern. Sine, sine, cosine, cosine, plus, plus, L1, L2, theta 1, then theta 1 plus theta 2. So suppose you have one more joint, then probably you will have L3 times sine theta 1 plus theta 2 plus theta 3. Well, you can guess what's going to happen. And that's exactly what is going to happen if we define theta 3 the same way we defined. Okay, that's another thing you will see in a homework. So this was a very nice set of variables and coordinates. And this nice equation shows you that. Okay, there's one more thing. We will learn vectors and so forth. Once we learn vectors, then we will learn how to put them together to make a single vector here. Okay, I'm going to repeat myself again. Notes. Trig functions, sines and cosines are useful. Right. and show a pattern. That is very important, and that is a good sign of good choice in variables. Again, definitions of coordinate and variables are free, so therefore record them. Okay? Coffee break. Reverse problem. Remember the first when I started this lecture, I said you want to bring your robot's end effector to the position where the part is. So therefore, what it amounts to is that the end effector position is given. You want to go there. Okay? So what you want to find out is the angles of the joints. So given this, and find this one here. What we have done is the other way around, from here to there, right? This is called a kinematics. Kinematics. From joint angles, how to compute this one here. But here, it's the other way around. So, this is called the inverse kinematics, the other way around. And to do this kinematics from theta 1, theta 2 to x to y 2, we use sines and cosine trig functions, right? So whenever, when you go the other way around, you can guess that we are going to use the other way around. Arc sines, arc cosines, arc tangents. So we will learn those functions as very useful tools down the road. Especially this function. If you do know anything about the computer programming, this function is very handy. Okay. Well, those are later. Okay, that's fine. And that's the end of this lecture number 2. Thank you, and I'll show you this. This is a set of homeworks where different type of different definition of the angles are given here, and you will enjoy with one more joint here. Thank you.